f of x. So this is a three-part one. I do want to talk for just a minute about domain and range when we get there too. So 2x if x is less than or equal to negative 2. Negative 1 minus x if x is between negative 2 and 4. And negative 3 if x is greater than or equal to 4. Y'all want to do plug-in method or erase method? Me too. Good. All right, so I'll start with the first one, and a lot of times as I get more comfortable with these, I'll come over here and just put the points beside them. If y'all want me to do a table. Somebody asked in third block, could you just do an XY chart? And you absolutely could. So if it makes more sense for you to do this and find your points, then whatever way is easiest for you. But for this one, I'm going to start with x equals what? Negative 2, because that's where I start here with my inequality. And so when I plug negative 2 into this equation, I get what? Negative 4. So that very first point is negative 2, negative 4. Is it open or is it closed? Why? There you go. I need another x, and I need it to satisfy this inequality. So it says less than or equal to negative 2. Here we go. Well, somebody pick that up if you don't mind. I know y'all don't like doing that in here. In third block, they all race to pick it up. Yeah, Olivia. Thank you. So give me one less than negative 2. Negative 3. And if I plug negative 3 now into this equation for x, I get negative 6. So negative 3, negative 6, I'm at 4, 5, 6. Open or closed? Oh, it doesn't matter. Never mind. Ha! Because I'm going. Sorry. Several of you asked me that yesterday, though. You asked if you put a second point on the line, why am I not? If you put a second point on the line, does it have to be open or closed? And the answer is it's always closed when it's another point through the line. You won't get to holes in lines until you get to freak out. So the only one you're looking for open or closed are endpoints. All right, how about the next one? Again, I start with negative 2, right? And I plug it in. Well, negative 1 would be bigger instead of small. So it has to be, that's the only, now any number you want as long as it's smaller than negative 2. All right, when I plug negative 2 in, I get what? Negative 1 minus negative 2. Yes, 1. Sorry. Whoever said that, I didn't believe you at first, and I had to look. Open or closed? Open. Why is it open this time? There's no line under it, right? All right, so negative 2, 1. I'm going to put these points because when we do domain and range, we just may need that. This is negative 2, negative 4. This is negative 2, 1. Just so I remember, because my graph is not as accurate as yours. And then we'll do the 4. So we'll do the other endpoint there. So when I plug 4 in here, negative 1 minus 4 is what? What is negative 1 minus 4? Negative 5. So 1, 2, 3, 4. 5. And we just connect those dots. And then the last one. I start with 4, and if I plug in 4, what's my x value? I mean my y value? Negative 3. In fact, it doesn't matter what I plug in. It's always going to be negative 3. Is it open or closed here? Closed because of the line under, right? So 1, 2, 3, 4. 1, 2, 3. 4, negative 3. What x satisfies that? What should I pick for x? What's bigger than 4? 5. What is y going to be if x is 5? -3. Always -3, and that's the direction that it goes. Nope, doesn't matter. Doesn't matter. Still be that horizontal line there. Everybody's favorite part. How about the domain? So looking left to right for domain. Negative infinity to positive infinity. So it goes forever to the left and it goes forever to the right, and everything inside, you never get to a point coming across that you wouldn't have a piece of graph for x there. So it's negative infinity to infinity. How about the range? Negative infinity up to what? Good job, y'all. Is that a bracket or parenthesis? I hear both. Which one is it? Which one includes the number? Bracket includes the number, parenthesis does not include. So you're right, it's parenthesis. Because this is an open circle here. So range is from the bottom up. So as I move up, this one goes down forever, right? So negative infinity. I get here and this graph runs out, but there's a piece of a graph here, right? So as I keep moving up, there's graph, there's graph, there's graph, but this is the point where the graph never goes above. So that's the top part of my range. Range is always hardest for everybody for some reason. So one more time. So the segments are going to be whenever your inequality looks like this. And then if it does not, that means it goes on forever. That's a good question though. What else? Anything else on your homework sheet? Yeah. 8? Sure. Number 8. I can't believe there's one on here that had a really funky range. I can't remember what it is. But okay, so this one is h of x equals -3x if x is less than 0. And then -1/2 x minus 1 if x is between 0 and 6. Oh, look, this one's got different signs here. Did y'all catch that? And then x minus 7 if x is bigger than 6. Confused on this one? So all that's going to be are my endpoints there of my segment. One's going to be closed and one's going to be open. All right, so let's go through. Very first one, what am I plugging in? 0, because I start with this, right? So I plug it in, so I have 0, and if I plug in 0 to that little -3x equation, what do I get? 0. That's my start or my end point. Is that open or closed? It's open. Good job. I need an x to plug in that satisfies that restriction. -1, because that's smaller than 0. If I plug -1 in, what do I get? 3. So 1, 1, 2, 3. And this is the direction that I'm going. What? Thank you. I was like, y'all know it's not a negative times a negative, and I'm not even. Oh my goodness, thank y'all. All right, how about the next one? Start with what? 0. Plug it in, so I have the point 0, -1. Is that open or closed? Closed. You go by the first sign here. So this one's going to be closed. This one's going to be open. Huh? The endpoint, you go with the one that's closest to the endpoint, the one you're plugging in. So for this one, because there's a line under it, I'm going to make this one closed. 0, -1. But when I get to this next point, whenever I plug in 6, that one's going to be open because there's no line under that one. So if I plug in 6, -1/2 times 6 is -3. (1/2 times 6). I should probably show this for you. So -3 minus 1 is -4. So 1, 2, 3, 4, 5, 6. 1, 2. And this one we said is open. Bless you. I should have labeled these points again. Well, we know 0, 0. This is 0, -1. Just in case I need these in just a minute. 6, -4. All right, last one. Plug in 6. What do you get? -1. 6, -1. Is it open or closed? Open. And then what is an x that would satisfy that? Bigger than 6. 7. You plug 7 in here. 7 minus 7 is 0. Here's 7. So now domain and range. Domain. (-infinity to infinity). There are no holes. When one stops, the other one picks up and keeps going. Oh, are both of those open? Yeah, they are. What does that mean? They are. They're both open because they're both of these signs. So 6 is not in the domain, right? Do you see that? 6 is not a part of this graph. Nowhere on here can x be 6 because these are open. So let's think back whenever we talked about, whenever we talked about interval notation. If you need to leave just one value out, how do you do that? Do you remember? Yeah, a double parenthesis. Yep. A double parenthesis with a U in between. So I'm going to come here and do a double parenthesis on 6 and combine it with a U. And that says include every single number except 6. Leave 6 out. It essentially says x cannot be 6. But it can be anything else you want it to be. Now, if this dot had been, if this had been this way, it would just be (-infinity to infinity. Does everybody see why? Do you see that here for 6, there's no graph that goes with x equals 6? Because those open dots mean do not include. No, I hadn't done this one. I think one of them had, I think it's number 4 was the funky domain. Or the range, I can't remember. But let's do the range on this one. What is the very lowest point the graph ever goes to? -4, that's right. But it doesn't include -4, right? That's an open dot at -4. So I'm going to do a parenthesis, -4. And then I go up, 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 up. And I will usually take my pencil and just come here and go, okay, I'm going up, 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 up. When I get here, that graph stops, right? This graph stops right here. Is there anything above that? Well, actually there is, because this piece of graph picks it up then. Do you see that? So this piece of graph, so they're pieces, but you have to look at them as a whole. So then this one picks up and it goes up forever. So there's no place where there is no y. Do you see that? Where there was a place where there was no x, there's no place where there's no y. So -4 to what? Infinity. Does that make sense? So that was a little bit of a funky remaining range too. Anything else? That good? Okay, let me tell you what I want you to do. You'll need your computer for the first part, but not for the second part. So the first part you're going to do on your own, but it's going to walk you through, and it'll be a little easy grade, but it will help you hopefully concrete the domain and range. There is a link in Canvas For the Desmos classroom activity, you should, I want to make sure everybody can get in there. You should just be able to click the link and it take you straight to the activity. We do a lot of these, and sometimes we'll do them together with the class, and sometimes we'll do them independently. We're going to do this one independently. Hello. Go ahead while y'all are getting logged into that. That's out your sheet. This I really do think y'all struggled with this a little more than what y'all did. And anytime that happens, I try to get some practice where you can talk about it with your group. But after Desmos, this is what you'll do in your group. Not finish it. Did y'all get in? I haven't seen anybody in yet. So you'll just answer each question and walk you through. The graphs are interactive, so they make it really easy where you can drag things around and play with it and look at how things impact. But like this first one, he's saying, and if you see a dashed line, that means does not include, and if you see a solid line, that means does include. So he's saying something's wrong with the shading on this graph, that the domain is not correct. And so you will answer, what do you think is not correct, and type it in there. And then on the next slide, you're actually going to fix it to say what you think the correct domain is. These will usually start out kind of difficult, and you'll kind of go, this is a little weird. But by the end of it, everybody always says it really helps them to understand when we do these little things, because it is interactive. So don't get flustered or frustrated with it. You're welcome to talk amongst your group if you hit something you don't understand on it. And then you will work with your group through this. And I am here if you need. Everybody good? Okay.